Hey guys, welcome to Chapter 1, Section 7, Functions. So, what is a function? Well, a function is a very special kind of relation, right? So it's like a relationship between these numbers in our ordered pairs, right? But it's a special kind of relationship. And how is that relationship defined? Well, to be a function, all right, we need all values, inputs, maybe let's write all elements, right? We know that word now, elements. So we need all elements, values, inputs, right? In our domain, I'll put DOM. In our domain, all the elements in our domain map. Let's do black here. Map to, right? Map to, and this is the really important part, exactly one element in the range. So that's the question we're going to ask ourselves when we look at these ordered pairs, like a set of ordered pairs, and see, okay, is this thing a function? Well, I want to check, do all of the elements in the domain map to exactly one element in the range? Okay, in other words, do all of our input values or our x values give us exactly one output? So we can't have two inputs, right? Sorry, we can't have two outputs for one input. And this will be the easiest thing to do is take a look at this example. So let's go ahead and do that first. All right, so our domain, let's do that first in green. We've got, and we'll do a mapping because it's kind of easier to look at that way. Let's just do, and who cares about the order this time? We don't need it in least to greatest or anything like that. Okay, so here's our domain, right? Or our independent values, right? Our independent values. Also, this would be our input, what we put into this thing, this machine or this function, right? Maybe it's a function, we're going to find out. Okay, and so then we're going to take a look at our range, our outputs, and let's see, so we've got 8, -2, 7, and 4. So here's our range, and what's the same thing as range, right? Range is the dependent, right? Dependent or output, right? Okay, so and then we'll draw our relation. 3 maps to what? 3 maps to 8. 2 maps to -2. 4 maps to 7. And -38 maps to 4. Okay, so here's the question. Do all the elements in our domain here map to exactly one element in the range? Okay, well, 3 maps to only 8. So it only maps to 1. Good. 2 only to -2. So only one element. 4 maps only to 7, and 38 maps only to 4. And actually, this one is a extra special function. It's called a one-to-one function, but don't worry about that stuff. It is a function because it maps to exactly one element. Okay, let's take a look at the next example. All right, here's another example. Let's do the same thing and write our mapping, draw our mapping out. So we've got a -4. Okay, -4. Let's do domain first. 3. Oh, there's 2. So let's star these. So because we don't need to double, we don't need to write 3 2 times, right? It's a 3 is there, and then 4 because 3 is only, or I don't need a star under 4 though. 3 is only one number, right? So I don't need to write it out twice. So 3 and 4 is our, sorry here, 3 and 4, +4. So that's our domain. I'll just put domain. That's our independent or input, right? Imp, ind, and imp. Okay, and how about range? Okay, we've got 2, -6, 2, okay, star that one so we don't put it in there twice on accident, and 5, right? Because we're just listing the elements, so 2 is the same element as 2, so we don't need to write it twice. So we got 2, and any order, I don't really care about the order right now, right? -6 and 5. Okay, so let's draw our relation. Let's take a look. So -4 maps to 2. Good. Okay, 3 maps to -6. Nice. 3 maps to 2. And 4 maps to 5. Okay. So let's see. Our question that we ask is, do all of the elements in the domain here, all elements in the domain, map to exactly 1? I'm going to write this again in big letters. Exactly 1. Exactly 1 element in the range. Well, let's see. 4 maps to 2. That's 1 element, right? Doesn't map anywhere else. 3 maps to 2. And 3 maps to 6. Oh, how many elements is that? 3 maps to 2 and 6. So 3 maps to more than one element in the range. Algebra R. In the range. What does that mean? This cannot be a function. By definition, it's not a function. This 3 maps to 2 different places, so it is not a function. Okay, not a func. Okay, not a function. That's what we've concluded. And 4 maps to 5, that's fine, no problem. But this 3, that's a serious problem. We can't map to 2 different places. The domain cannot map to 2 different places to be a function. Okay, let's take a look at some examples on graphs. Okay, here's some graphs. All right, now they have this thing called the vertical line test. Vertical line test. Try to write this somewhat neatly. The vertical line test. That's what we do to check to see if we have a graphical representation of a function. I can check to see if it's a function, or representation of any relation. Check to see if it's a function by taking a line and drawing that line across, or take your pencil. It's even easier. It's a pencil test, right? I think that's what they called it when I was in school. You take your pencil and slowly drag your pencil vertically. So here's your pencil, right? There's your pencil. It's got an eraser. That's a terrible drawing. Sorry. So you drag it across the function this way. So I'm going to have I can test each line here, and I can see, look, oh, it's only passing through at one point each time. Oh, here, right? It's only passing through at one point everywhere along the function, even down here, right? It's still only passing through at one point. What does that mean? Well, it means for each x value, right? When I choose an x value, like say this is -1, 2, 3. Say this is -4. Well, how many y values do I get at this point? I'll use another color. How many y values do I get at this point? I only get 1. Okay, so how about at -3? -1, 2, 3. How many y values? Only 1. Again, only 1 at -2. Only 1 at -1. So you take your pencil and drag it along. Drag it along your function, and to see if it passes that vertical line test. All right, so we can do the same thing for the next one. And so maybe right here. Let's see. Maybe right here, our vertical line test looks good, and even right here, it looks pretty good. There's only 1 point, I think. 1 point it passes through. But how about I'll do this even in another color. How about right here? That's not very vertical. Let's do a nicer looking one. Let's do purple too. Let's do so just pretend that's totally vertical. Look how many points it passes through. There's one. We'll do the points in red too, and there's one here, one here, and one here. What does that mean? What does that mean? Well, at this point, at this value here for x, right? At this value for x, I know this is getting a little bit crazy looking, but at this value for x right here, we have how many red spots, or how many f of x values, or y values, or range values we actually have. We've got 1, 2, 3. So this is not a function. So I'll put an x through it. It cannot be a function, because at some point along this line, along this graph, we have for a particular x, I have 3 y values. I don't have exactly 1. I have 3. So that's a problem. Not a function. How about this next one down here? Okay, I'll take my pencil and do my vertical line test. And how's this looking? This one's looking pretty good. This one's looking pretty good. We can see that we're passing through exactly for this x value here. I'm getting exactly 1 y value. Same here for this x value, 1 y value. That's why we use a vertical line, because it does it kind of without us even having to think. X value, 1 y value. Even at 0, there's 0. Y can be 0. That's totally fine. Looks good along the graph. So there's exactly 1 value. How about the circle here? You guys probably guess already. Well, I can only need to draw 1 line, 1 vertical line. Take a look. At this x value here, let's say it's -1 maybe, how many y values, or how many output values do I get? I get 2. 1, 2. So here's for every input, I need exactly 1 output. So this cannot be a function. This is not a function. So not a function, not a function, because I have more than 1 output for this particular x value. Same here. For this particular little x value here, I've got 3. 1, 2, 3 outputs. Okay, so these guys are okay. So that's okay, and this one's okay. So there's a check, right? Yeah, it is a function. It is a function. These guys, no go.